Good morning. Today we are going to discuss Chomsky hierarchy, the last portion of an important portion of theory of computation, that is Chomsky hierarchy. Up to now, we have discussed these are the languages: type 0 grammar, type 1, type 2, type 3. Type 0 grammar is otherwise called unrestricted grammar. Type 1 is context sensitive grammar, context free grammar, and regular grammar. And the tools are for accepting this unrestricted language is Turing machine. This is linear bound automaton. This is push down automaton, and this is finite state automaton or finite automaton effect. Type 0 grammar, type 1 grammar, type 2 grammar, and type 3 grammar. Type 3 grammar is having the general structure which is A derives A alpha or A. See, this dot A alpha. A derives AB or BA or A. That means on the right hand side of every production, it should start with a terminal or end with a terminal or a terminal. It is deriving a terminal followed by a non-terminal, a non-terminal followed by a terminal or a terminal. If all the productions are of this form, can easily construct a transition diagram of finite automaton from this, and this is called type 3 grammar. Type 2 grammar is having the structure A derives A alpha. That means it is not A derives A alpha, A derives alpha. A derives alpha means this A always stands for A is a member of variables. And here see our grammar is represented by G is equal to V T P S. That is variables, terminals, productions, and start symbol. And this A stands for V, and alpha stands for alpha is a member of V union T star. That means this alpha is a mix of variables and terminals, or variables, terminals, or variables and terminals, and then it's a string of variables, terminals, or variables and terminals, that is V union T star. And if this type 2 grammar, the left hand side is a single terminal, and on the right hand side you can have any number of terminals, non-terminals, or terminals and non-terminals. And type 1 grammar is alpha derives beta, and the condition is modulus of alpha less than or equal to modulus of beta. That means left hand side as well as right hand side is a mix of terminals, non-terminals, or terminals and non-terminals. But if you are calculating the length of this, that means number of symbols in the left hand side and number of symbols on the right hand side, then this is length of left hand side is at least as large as the right hand side. That means this length of this is less than or equal to length of right hand side. And type 0 grammar is having this unrestricted alpha derives beta. That means there is no restriction. And the hierarchy is like this. That means if you have this is unrestricted grammar, this is unrestricted, and this context sensitive grammar is a subset of that. This is C context sensitive grammar, and this is a subset which is context free grammar, and inside that you have this is a regular grammar RB. See, this is unrestricted grammar is accepted by Turing machine. Context sensitive grammar is accepted by linear bound automaton. Context free grammar is push down automaton, and regular grammar is finite automaton. So this is the Chomskyan hierarchy, and as far as theory of computation is concerned, this is very important. This is very important. That means um, the superset is unrestricted grammar, and its subset is context sensitive grammar, and context free grammar is a subset of that, and finally a regular set. That means the most refined form of the grammar is regular grammar, and actually theory of computation is regarding the study of grammars. There are four types of grammars: unrestricted, context sensitive, context free, and regular languages. And the tools or automaton which is accepting those. Study of different languages and the tools for accepting those languages. That is the study, or that is all about theory of computation. And the final one is the Chomsky hierarchy. This is the derived by Chomsky, and that's why we have the name Chomsky hierarchy. Okay, that's all about Chomsky hierarchy and theory of computation. And with this, I am concluding this session as well as course. Thank you.